Okay, picture this, the nervous system of a brand new skyscraper, or maybe a massive international airport. You've got literally thousands of lights, sensors, and systems that all have to communicate with each other flawlessly. How is that even possible without complete chaos? Well, it requires a blueprint, a kind of universal language, and today that's exactly what we're exploring, the blueprint known as the KNX standard.
To really wrap your head around the sheer scale of KNX, let's just start with a number, 65,536. That's the max number of individual devices, and I mean every light, every thermostat, every security sensor, every window blind, that can all talk to each other on a single unified KNX network. This is not your home network, folks. We're talking about the backbone for an entire intelligent city block.
But here's the really wild part. To manage all of this, there's no single central server, no master computer that can just fail. The whole philosophy here is a radically decentralized, distributed approach. You see, every single device has its own little microprocessor. They form a kind of collective intelligence, a true network where no single component is the boss.
And that, right there, brings us to the most important question. How in the world do you build a system on this massive scale, keep it rock-solid reliable, and make sure that if one little piece fails, the whole building doesn't just go dark? Well, that is exactly what we are going to break down in this explainer.
So how do you get that kind of reliability? It all comes down to the structure. We're going to build a KNX network from the ground up, starting with the most basic, fundamental pieces. So the smallest unit is what's called a physical segment. Really, it's just one continuous piece of that green KNX bus cable, and it can be up to 1,000 meters long. As you can see, you've got a couple of options. A TP164 segment, well, that can handle up to 64 devices. A TP1256 can manage up to 256 all by itself. Think of this as the local street, where all the houses on the block are connected. Okay, but obviously a single street isn't going to be enough for a whole city, right? So what happens when you need more than 64 devices, or the building's layout just needs a longer cable run than one segment can handle? This is where things get really clever. You start with one of those segments, and then you add a special little device called a repeater. Its whole job is just to boost and clean up the signal, which lets you connect up to 4 of these segments together. And this bigger structure, that's called a KNX line. Just like that, we've upped our device count to 256, and we can spread them out over a much larger area. All right, so we've gone from a single device on a segment up to a whole line of devices. Now let's zoom out again and look at the next level of this whole hierarchy. So the next key player is the line coupler. You can think of this as a smart little router. Its job is to connect our line to a much bigger highway, which is called a main line. But, and this is so important, it's also a gatekeeper. It keeps all the local chatter, like a light switch talking to a light right in the same room, on that line. This prevents the main highway from getting all clogged up with traffic it doesn't need. And this is where the scale just explodes. Using those line couplers, you can now connect up to 15 of the lines we just made onto a new, bigger highway called a main line. This whole collection, the main line and its 15 connected lines, is what we call an area. And just like that, we've gone from managing a couple hundred devices to thousands, all grouped together logically. And believe it or not, we are still not done. To connect different areas, like say the entire east wing and the west wing of a huge hospital, we use an even more powerful router called a backbone coupler. This thing connects the main line of an entire area to the system's central nervous system, the backbone line. And here it is, the whole shebang. This diagram puts it all together. You can see that backbone line running across the top, connecting up to 15 complete areas. And each of those areas has its own main line, connecting its own 15 lines. And boom, we've built the full KNX domain. 15 areas, each with up to 15 lines. That's how we get to that massive number of over 65,000 devices, all living inside this single, incredibly organized structure. So we've built this massive physical network. But how does any one device actually know how to talk to another one? This, my friends, is the aha moment. This is where we see how the logical addressing system is a perfect mirror of the physical blueprint we just put together. Every single device in a KNX system gets its own unique 16-bit address. But it is not just a random number. It's actually broken into 3 distinct parts. The first 4 bits tell you which of the 15 areas it's in. The next 4 bits tell you which of the 15 lines inside that area it's on. And the final 8 bits? That points to the specific device on that line, from 0 to 255. Honestly, the best way to think about it is like a postal address. Let's say a device has the address 1.15.255. That 1 is the area. Think of it like the city block. The 15 is the line, so that's the specific street on that block. And 255 is the device itself, the house number on that street. It's basically an instant location finder built right into the name. And that's really the genius of this whole system. A device's address isn't just some random ID number. It is its literal location on the network map. Just by reading the address, any other part of the system, or, a technician, knows exactly where that device is inside this massive building topology. So we've seen the how, but let's finish up with the why. I mean, why go to all this trouble to create this complex, hierarchical system? What's the payoff? Well, it comes down to 4 huge advantages. First, massive scalability. It can run a tiny apartment, or it can run an entire airport. Second, radical reliability. Because it's decentralized, there's no single brain that can crash and take down the whole building. Third, it's super efficient with traffic. Remember those couplers? They act as filters, making sure the main network doesn't get clogged. And finally, logical management. The fact that the address is the location just makes setting up, troubleshooting, and managing tens of thousands of devices incredibly straightforward. So at the end of the day, KNX is really more than just a bunch of cables and addresses. It's a design philosophy. It's a blueprint for building a system that's resilient, that's scalable, and that's intelligent from its very core. It really makes you wonder, as our world gets more and more connected, what else could benefit from a decentralized model like this, one that's designed from the ground up to never fail?